I'm super happy to welcome today pyannoteAI. So I'm sure you know pyannote. I'm not sure you know pyannoteAI yet. And I'm so happy to have one of our first partner of the company. They've been supporting us for quite some time. I'm going to explain that a little bit after. But pyannote is a specialist, are the specialist into speaker diarization, so speaker separation. And the topic we're going to address today, it's the future of voice intelligence. And that's personally my belief in Gladia. So we're going to split the agenda into and now you understand pyannote is open source, but no is a company, and Hervé and Vincent is going to explain that. We're going to have a deep dive by the, I would say, world expert, which is Hervé, regarding diarization, a bit of use cases regarding diarization, and we're going to explain how Gladia has been implemented that in real life with their customers, and then a bit more on the speaker insights and the questions and the Q&A. So you will have plenty of time at the end to handle the Q&A. Joining me today are two amazing people. Hervé, that have been known for quite some time and is very well known in the speech community. Hervé is the brain and the mind behind pyannote, which is the library, the open source library for diarization. And I'm so happy that Hervé is there because I have to tell you at the beginning of Gladia, diarization was one of our biggest problems, and Hervé was there even before I started pyannoteAI, along with Vincent, and Hervé has been a supportive a member of Gladia community since the beginning. And Vincent joined him to create pyannoteAI a few months ago. And they're starting a company, and we're super proud partner of them and user of them. So the floor is yours, Hervé and Vincent. Let's go and present your baby and the diarization, the beautiful world of diarization, which is, I have to say, the biggest problem I've seen in machine learning in my 16 years of experience. Good luck to that.
Thank you, Jean-Louis. Thank you for the kind introduction. Yes, indeed, it's a difficult problem. I've been working on this particular topic for the last 12 years, I think, as an academic researcher, so focusing almost all my time on this particular question. So it's indeed a complex problem. So speaker diarization is the task of answering the question, who speaks when in a conversation. As an academic researcher, as I said, I've been working on this for a long time, and my mission as a researcher was to make my research reproducible and usable to a lot of people, as many people as possible. So my way of doing it was to create this open source toolkit called pyannote. So basically, all of my research results went into this library, and this library grew with me over time. So right now it became quite popular indeed. We have a few numbers here, but basically there are 7,000 GitHub stars, and we have 100,000 unique users on the Hugging Face platform, where we share pre-trained models. Those pre-trained models are downloaded 30 million times every month. So if you actually rank on the Hugging Face platform, the models, the audio models on the Hugging Face platform, out of the 10 most popular models, 4 of them are from pyannote. So I realized only very lately that pyannote was so popular. You know, as an academic researcher, I was focusing on my research, but not really realizing that everybody was actually using it. It's really when Whisper from OpenAI came out that, I think it was in October 2022, that I saw lots of open source projects combining Whisper and pyannote coming out, because Whisper would provide very accurate transcription, but nothing about the speakers. So actually, people turn to pyannote to combine the two, and this is really where the idea of creating a company around pyannote came out. And this is also after that I met Vincent, and I guess Vincent, you can start from here to talk about pyannoteAI then.
Sure, and thanks again, Jean-Louis, for this kind introduction and for having us today. Let me connect the dots between the green logo on one side of the slide and the white logo on the other. As you said, we actually, it was one, I just do the math earlier today, but we actually met with Hervé 1 year, 2 months, and 3 days ago. It was because we actually met like 9 years ago, but we met at the beginning of last year. And Hervé explained to me what he has been like working on for more than a decade as a researcher, and how what struck me at the time is this particular focus and unique focus on the speaker, and really focusing on the speaker and on the speech, and how deep, complex, and hard the problem he was trying to solve was, and how crucial it was for many, many people in the space. And also, he was delivering it in a way that actually like was very reassuring, because he was not like a mad scientist in Toulouse countryside, but a real person that was engaged in a community, working on something that actually could bring value to the community and specific users. So we start digging. We trying to see if there were like a real problem to solve at scale. We are trying to understand what people would expect from us and how the entire ecosystem was moving, and how it makes sense to focus on the speaker problem. And quite quickly, we connected the dots. It was so obvious that the voice AI age we are entering is actually bringing the gap between voice and the permanent, well, between voice and permanency of text. And at the beginning of everything, there is a challenge, actually. It's the ability to separate speakers as effortlessly as humans do, actually. And that's why we are building pyannoteAI. So we are really focusing on building this speaker platform that can like empower developers and people in the space to actually build products in their own vertical without the complexity of identifying, segmenting, labeling, or separating speaker at the beginning. And we really want to do it like everywhere it matters, in batch, in streaming, whether through an API, on premises or on device, everywhere that makes sense for our community. And we want to be that platform that enables a future where actually all audio-based AI systems naturally understand speakers without friction. So that's the mission we are in, and we have been working deeply with and building an incredible team around us to actually try to crack this very difficult problem. And I will let Hervé share a bit of how difficult it is, and that's to see how complex this topic is and how we can bring value along the chain in a crowd time. Hervé, mic is yours.
Yeah, so diarization is a weird word, so I wanted to spend some time what it means exactly and what it's not, what it is and what it's not. So here on this slide, I'm talking about the speaker recognition umbrella term that actually covers a bunch of different applications. So just so that you understand why speaker diarization is not your classical machine learning problem. So bear with me for the machine learning jargon here, but so basically here I'm presenting 3 different machine learning tasks. The first one is let's say the simplest. We call that speaker verification. So it's a supervised classification task in the sense that we are provided with a sample of speaker A. Can I actually use my mouse here, or is there a feature for this thing or not? I should have asked before. Do you know, Jean-Louis, if I can? No, probably not. But anyway, we are looking at the speaker verification rectangle here. So basically, the algorithm here is given an example of speaker A. It's the blue one on the left. And then in the middle, there's a new example coming in. And the question asked is this speaker A speaking in this recording? And the answer is binary. So it's a binary classification task. And we provide only one answer for the whole utterance. So that's why I call that utterance-wise binary classification. So it's a yes or no question. When we go a bit further and closer to speaker diarization, there's speaker identification. In this example, we are provided with a bunch of training samples of various speakers, here speaker A, B, and C. And at test time, we are given a new recording and we don't know who that speaker is, and we are supposed to answer A, B, or C. So it's a multi-class classification task. It's supervised in the sense that we are given training samples, and it's utterance-wise in the sense that we provide just one answer for the whole recording. And then there's speaker tracking, getting closer and closer to speaker diarization. In the case of speaker tracking, we are given an example, once again, of speaker A. And the question is, when does speaker A speak in this particular conversation? So it's very similar to the speaker verification task, except now we are supposed to provide a frame-wise answer. So basically, for every instant in time, we call that frames usually in the audio processing community, we are supposed to answer the question, is for this frame, is speaker A actually speaking? So it's also a binary classification task. And now we are getting to speaker diarization. So speaker diarization is an unsupervised task in the sense that we have no knowledge a priori about the speaker who are involved in the conversation. Not only do we know who they are, but we also don't know their number, and they are probably never heard during the training process. So in that sense, it's unsupervised with regards to the actual speaker involved in the conversation. Similar to speaker tracking, this is also frame-wise in the sense that we are supposed to give an answer for every frame in the audio. And it's similar to what we call clustering, a clustering task in the machine learning community. So basically, clustering is making groups of things. And here we are giving the same color in this example to the same speaker. So this is really what speaker diarization is about. So, and that's why it's different from supervised classification task. We are not supposed to answer the question with an actual identity of the speaker, but we will say this is speaker one, this is speaker one, this is speaker one. Those are the same speaker. This is the same speaker speaking at this particular time. And then we might also actually give another label to this speaker, but that would be still correct. Any permutation of the problem is correct. So that's really, I think, the main reason why this is a very difficult problem to solve. There are many other reasons why it is a challenging task. Here I list 4 of them. The first one is that we are supposed to recognize a speaker even though the speech turns can be very short. That's actually usually the case in very spontaneous conversation, like in any meetings, or even here, if someone would speak a very small yes or no in the middle of my sentence, we still need to get these very short speech turn. If we miss them, we might actually miss the main information in the conversation. Another problem is the fact that we don't know in advance the number of speakers. When we know it, it makes the problem easier. We can talk about that later, but we also have to estimate the number of speakers, and because we might make 2 types of mistakes. Whether we have 1 speaker and we split it into 2 speakers, that might be a problem for some use case, might not be a problem for others, or we might actually merge 2 speakers in the same one. And depending on the use case, which I think Vincent is going to discuss afterwards, it might be very critical. The third difficulty is overlapping speech. Overlapping speech is actually everywhere. We don't realize that when we interact with someone, but it's everywhere. Here is an example of a meeting between 4 people. So on the x-axis, you have the time, and the colors are actually every speaker. And in this particular example, up to 40% of the speech is actually overlap speech. So that makes the problem very difficult, in particular for transcription, obviously. Transcribing overlapping speech is a mess. But even for diarization, yeah, you agree, don't we? And it's also one thing to detect overlapping speech. You could just detect overlapping speech and get rid of the overlapping speech region because you know the ASR will behave poorly. But that's another problem to not only detect, but also assign correctly to the right speaker. And another problem that's more related to the clustering step here that I mentioned in this slide is the fact that we might have one speaker speaking much more than the others, and that makes the clustering step very difficult, and we don't want to miss that. So that's a very high overview of why it's a very difficult problem and why I have been working on this for 12 years and still haven't cracked it. But we are working on it. I guess we can switch to the use case now, Vincent.
Yes, I would love I would love to know how many people are like taking medicines for headache after this for 4 minutes of presentation. It's a really complex topic and really like linked to real life conversation and real life interaction. So it's always a challenge. What we wanted to share here is some sense of how we can help actually our community or our clients, whatever the type of product we are serving. So maybe let me give you 3 examples. The first one is obviously in the speech to text industry. Sometimes we came across incredible people, incredible teams, and partner with them, and we are super happy to do that. Maybe you will see who I'm thinking of at this moment, but people like building audio infra to transform user experience or customer support, that kind of team that we partner with and here, but maybe Jean-Will, you will describe it more deeply later. But here we are helping in the for meeting notes, for call centers, to be able to obviously to identify who speaks when in the conversation. So that's the main, for us, obviously a main way to help our customers. And maybe let me walk through two other use cases. The second one is the dubbing industry. We help people streamline their localization process. We actually help them basically put the right voice at the right moment to the right character in a film. So we are providing the tools to put the right voice at the right moment, but also with tools like confidence score, that kind of tools around diarization, to help them to reduce human post-processing after using after localizing some content. We also help them to label audio content, like with labeling with the name of actors, for example, and it's improved the way they can index content on search across large data set of audio. The last use case I will just mention quickly is actually in the world of training voice AI or training multimodal LLMs. So it's public, but for example, Moshi of Qtai have been trained using pyannote, in the sense that we actually provide a way to create clean data set of audio to train voice AIs and avoid these artifacts that I've been discussing just before, like with having overlapping speech that would be mixed at the end of the funnel in the voice AI. So we are super happy. We are happy to actually serve people in many industries, in many use cases. What we actually didn't say Hervé, but it's implied that we are based on the sound of voice, not on the words. So everything we do is language agnostic. So we are used from San Francisco to Tokyo, no matter which language you use. Even, and I know you like to say that, Hervé, often, is that even for languages that have not been used in training, diarization models are actually quite good. So we are really trying to solve this problem across different industries and across different languages. So that's a tough question, but happy to see that we can bring value. Maybe we can deep dive in how we are working together, Jean-Louis?
Definitely. I will explain the pain points that we have and had with diarization over time. So we actually have part of our implementation that was in-house and part of the implementation that's been done through pyannoteAI. And I will explain if you're building a similar system, why it's important to be a hybrid. there are some cases where maybe for some reason you want to have your diarization internally. But the main problem that you have with pyannote, and I will go a bit in details, is that, as Hervé mentioned, in real life, it's extremely cost computing on the one hand. So you need to have performant algorithm that run in the time that is appropriate for the transcription and to be like kind of combined in the end. And the time of diarization is kind of very, I would say, compute intensive and very, very long. And among the problem that you have, that Hervé has been presented, you have what is called unsupervised clustering. So you don't know exactly the number of people you're gonna have. So imagine a bag of items that you have, and I'm thinking a lot about my kids when they have like this pearl on the table, and you have to say make some bubbles with it, and you need to choose how many bubbles you're gonna have, how many groups of pearls you're gonna have. Is it 5? Is it 7? Is it 3? It depends a lot on the people, and those algorithms are extremely compute intensive. And some of the problem that we had and that we are happy that we solved thanks to pyannote was to make sure that we were able to have those bubbles or those bags being as precise as possible, compute in the most accurate way in the smallest amount of time. And that's extremely challenging. So that's why we decided to go with hybrid systems when we have two diarization. One is called enhanced, and it's actually running on pyannote, which offer a high-grade diarization. And there are some cases, and a lot of cases, where you want to have this high accuracy and better compute. And we were happy to partner with pyannote to handle those cases, which is the large majority of the choice of our customers. So the pain points are compute. And friends, I think it was Jensen Huang, the CEO of NVIDIA, that says friends don't let friends build data centers and GPUs and rack GPUs into data centers. I think friends don't let friends build their own diarizations. That's what that would be my keynote of the day. And that's why I'm so happy that through all the years that we've been working together, you guys decided to start a company because we need a strong company to actually support this open source initiatives. And that's, as you said, very well used in the industry. We use it for training, actually. Vincent, I never mentioned that, but we do actually do some diarization for the training. So that's a good example. And a lot of TTS, text-to-speech providers are using it to actually train their model to have better text-to-speech training sets. All in all, maybe we can move to the next section when I'm going to show you some of our customers. I would like to highlight two of them, which is one of them is Circleback that we love a lot, one of the early adopter of Gladia. They do have an extremely well implemented diarization. As you can see, they're able to spot the speakers, and thanks to the enhanced diarization, they're able to have like an extremely well timely defined diarization. This is their implementation. It looks, you can see what is called the speaker turns in their UI. And the great thing about Circleback, you don't see my mouse, but you have the assistant and you're able to prompt the transcript, and the transcript is actually able to spot who's speaking when and to have those kind of interactions. So speaker attribution is a massive problem. And I'm going to move to the next one, that clap, and I'm going to show you very quickly that diarization is one of the key systems that you have to have right. Clap is a sales enablement platform, right? And as a salesperson, as Hervé mentioned, you might have some objections coming from your customers. They're going to say yes, they're going to say no, they're going to interrupt you in some ways. You have to pick what has been said exactly and attribute it exactly to the right person. Otherwise, your CRM will be broken. That's very simple. If you miss that, then you miss the intention of the buyer, means and all these notes and prompts, etc., are being pushed into ChatGPT or whatever LLMs, and then pushed into your CRMs to have evaluations. You break the diarization, you break the intention of the buyer, you break completely your flow. So this is how diarization is a key to everyone. And same goes with medical notes. If I break the medical notes, maybe I said, what do you take as a drug? And maybe as a clinician, I'm going to list a number of drugs, and then you're going to reply with the drug that you actually take. If you miss the two, maybe you're going to attribute the drugs to the wrong person. Was it the clinicians or was it the patients? You miss it, you missynchronize your systems, you make a medical error. This is how diarization can change definitely the way you are able to be precise in your business processes. So my point there, transcription is important. Diarization is as important as transcription and shouldn't be forgotten. And honestly, in 16 years, that's the biggest and the most challenging machine learning problem I've faced, and I'm happy that you guys are there to help us on that. And that's how we partner, and I'm sure there will be some people there that will be partnering, and even some competitors that are sometimes in the chat. I mean, they should look at you. I mean, you guys have achieved something extremely well. You should, guys, look at pyannote, because it's becoming the standards and definitely needs to be taken into account in your pipeline. So thank you so much for the presentation, Hervé and Vincent. Really appreciate that you guys took the time to go there. I know you're super busy, but that was, like, I think, a very important topic to share. We are open now for questions in the Q&A sections. Feel free to ask your questions. And I will leave that to Anna to do the routing of the questions. Anna, you there?
Yes.
Perfect.
Yeah, so we have a first question, which is related to, I guess, what Hervé mentioned, but maybe we could go into a little bit more detail on that. And the question is, how does speaker diarization handle more complex scenarios, such as multiple speakers talking over one another, and how accurate is it in those cases? Would you like to take that one, Hervé, maybe?
Yeah, definitely. Actually, speaker diarization only makes sense, or it's not completely true, but when there are at least two speakers in the conversation. As soon as there are multiple speakers in the conversation, as Jean-Louis also highlighted, it's very critical to know who said what. So there are, in some cases, like in the healthcare industry, like you said, Jean-Louis, knowing who said what is actually just as important than what they say. And so, it's really critical in that particular cases. And so, regarding the overlapping speech, people talking on top of each other, it's as I said earlier, it's a very not only how should I frame it? It's very difficult to first detect those particular regions where people are talking on top of each other, and I think this is really where pyannoteAI is shining compared to the competitors. I think in the 10 years that I've been working in the past, I spent a considerable amount of time focusing on this particular question. First, detecting overlapping speech. So I worked for that for a few years actually. And then once this is detected, actually assigning to the right speaker. And that's another level of problem. And then the next step, obviously, would be to go to speaker separation, where you actually, once you detect and assign correctly, you actually create two audio streams where you only hear one speaker in each. This way, if you apply a transcription in separated streams, then you can expect a much lower error rate, in particular on those regions where speakers.
You know, Hervé, that's my dream. That's my dream. You know it.
Dream will come true later this year.
Can't wait to see it. We have plenty of questions in the chat, Anna.
Yeah, I can see that. Thank you, Hervé. So we have a question from Alex, who says he's very glad to see everyone here. And he's asking, are you guys using both audio and video diarization at the moment to reduce the error rate?
So is this a question for us? At least I can answer for pyannoteAI, and Jean-Louis may be able to answer for Gladia. At pyannoteAI, we only do audio processing as of today. Once again, in the past, I did work on the equivalent of speaker diarization, but for video. That's basically face tracking and clustering. And indeed, there are plenty of use cases like indexing of, I don't know, Netflix episodes, where it totally makes sense to combine face clustering and speaker diarization. But on our side, at pyannoteAI, we focus on audio, and this is what we do best, and we'll continue working on this. Yeah.
And I will add on the product side, on my end, on the I would say API side of transcription. That's a very good questions that we get from a few meeting recorders. The problem you're gonna have with that is that first, video is pretty heavy in terms of size of file. So the first thing you're gonna have cost, infrastructure cost that's gonna go with it. The second thing is like video tracking can be a bit compute intensive, and it's going to cost you another probably twice the price of the diarization that you have in sound. So the question you may have is, yes, you might gain maybe a few percent, but do the few percent worth the twice the price you're willing to pay as a product? And if I think about meeting recorder, which is the use case that might be probably the most accurate when it comes to video analysis, the cost of your transcriptions is usually a good portion of your overall cost in your business. So would you be rather having a higher accuracy based on the phase where sometimes you might be a little bit better, but have a cost that's going to be way higher? And on Gladia side, and that's how we see it, we don't feel that the market is ready to pay more unless we have like cheaper algorithm. But if we have cheaper algorithm, people are probably more willing to pay less rather than having an extremely highly precise based on the voice, the lip sync. That being said, the algorithm that Hervé has been mentioning, like speaker identification, etc., speaker identification, can be combined with diarization to be a bit more precise in some ways when you had some business logics. For instance, I know from a meeting recorder standpoint that I have this email, so this person is going to be joining the platforms. I know they've been there in the past. I have their voice print. So maybe there is a way that I'm going to boost a little bit their voice print. So there are many ways that you can do those things, but that's not going to be as compute intensive as video. And yet you can get some good, tricky improvement this way. So this is our position as Gladia, and Hervé has mentioned that it's doable, but I'm not sure economically it would make sense.
And if I may, Jean-Louis, fully agree with everything you just said. Just maybe adding a little thing here. In use cases like localization for content for very like films, series, that kind of type of content, this trade-off tends also to be a bit challenging. That they're trying to see how they like maximize the ability to have the perfect file at the end. So from time to time, we also see people that are likely to invest the amount, all the things you just shared earlier, to find the most accurate way to actually localize content at large scale for large platforms. So again, fully agree with what you said. Just maybe in some types of use cases, the trade-off may be slightly different.
Yeah, absolutely, and that's a general view that you will see in the market. I'm seeing people asking questions about 11 Labs in the chat, and others. You have something when you build an audio product and audio-based product or video-based product. It's either you do low price and high volume, or you do low volume but you need to have a high price. And the example that Vincent was giving, Hervé was giving about Prime Video or Netflix, you have low volume, but you have huge major in front of you. So you can authorize yourself to have a high price. Maybe it's, I don't know, $100, $300 per hours. But then you have a human-based transcription, human-based like diarization, or human-based optimized diarization, where you can have a predefined diarization that's been made by an algorithm, and then you have a human that's going to adjust the timestamp to be extremely well-defined. But it all comes to high volume, low price, or low volume, high price. And that's what Vincent is saying. There are some cases when you are authorized to do that because you are low volume, high price. But that needs to go with your marketing positioning and your go to market in general. So fully agree with you, Vincent, on that. And now we have a few other questions in the chat.
Yeah, there are a few that I'm trying to merge into like a broader question. So people are asking about the different conditions, I guess, that can influence diarization and how it performs. So one was related to non-speech sounds, like environment sounds and music. How does your technology respond? Does it categorize it into a separate class, or what happens? And another question related again to music and certain effects in the mix that add like emotion and can affect the voice. How would that affect as well the accuracy of your models?
Yes, so like for any automatic speech processing techniques, the more background noise, the more difficult. Obviously, that's a given. So basically, speaker diarization really focuses on speech, and so we are obviously training our models with music in the background, with various noise in the background, but it's trained to only focus on speech. So it should and it is robust to this kind of background noise, and so we are not training the models to actually tag music, not yet. To tag music, coughing, or other environment noise, but basically this could be something that we might consider in the future. But right now, yes, focusing on speaker diarization only. So the output would be just one line per speech turn, start time, end time speaker, and that's it, and kind of erase the rest of the information. I'm not sure I answered the whole question, but.
Do you use data augmentation in your training process, like adding background noise and going down to 8 kilohertz for like telephony, adding some overlaps, etc.? Do you do those kind of systems in your training?
Yeah. This is the kind of stuff that we are actually trying, comparing. It's always a mix between different type of data augmentation. So yes, among them, you mentioned adding background noise, adding artificial overlapping speech is probably not such a good idea. I did that in the past, but actually you end up with artificial overlap, which are not natural, and the model will actually not behave accurately then when it actually encounters a real overlapping speech. Those are usually very specific either. And one thing that is very interesting about overlapping speech is that overlapping speech is not always really overlapping. Humans are really good at putting just a small words in small pause of their the people they are talking to. If you are very careful and listen carefully to a conversation between two people, we are very fast at jumping and taking a word in the middle of the sentence of someone, and it's sometimes not even overlapping. But those are very tricky to detect anyway. Yeah.
Anna, thank you so much for the answers. Anna?
Yes. There was also a question of that I found quite interesting, which is, what does pyannote bring technically in terms of diarization and overlapping speech compared to Hervé's open source library? If I already use pyannote audio, I can manage the computing cost and implementation with transcription. Why should I consider switching to pyannoteAI and or Gladia?
Vincent, do you want to take it, or should I take it?
Yeah, sure. And feel free to add. I think, well, you know the open source toolkit that you've been maybe testing. What we are bringing with pyannoteAI, the AI version of what we are doing, is first, at the core, basically the next generation of diarization model. That means that, and Hervé, the credits are yours, but we've been building this technology and this new generation of diarization models that actually are larger, train on more data, and actually are bringing to the field two main outcomes. First, and you mentioned it earlier, Jean-Louis, we are like providing a much better product in terms of accuracy. Accuracy is always a topic. You can see it. It depends on how you look at it. But when we try to make a sincere assessment of our technology across large data sets, we can evaluate that we are more or less 20% better than the open source toolkit that you may have used in the past. So accuracy is a real focus and a real new thing that we are bringing to the table. Depending on the type of data, sometimes people say that it's quite the same as the open source toolkit. Sometimes they say that it's blowing out of the water the previous performance. So that's why I'm cautious saying that it's an average. The second thing, we are actually we've been working a lot, and that made a lot of sense, especially when you have large scale data and you have a lot of volume to actually process, is the performance in terms of speed. Today, to give you an idea, on a H100 GPU of NVIDIA, you can process 1 hour of audio within, I don't want to say stupid things, but more or less 50 seconds in terms
15.
of...
Yeah, 15.
50. No, I was referring to the open source toolkit.
Oh, yeah, sorry.
More or less 50 seconds to process 1 hour audio with the open source toolkit versus more or less 17 seconds for the pyannoteAI model. So basically working on the two core parts of the product, accuracy on one hand and speed on the other. And beyond that, and that's actually a thing that we are building around Diarization, we are building stuff that actually helps people in their use cases. I was mentioning earlier the localization and all the post-processing made by humans. Alongside with the Diarization, we are providing confidence scores that tells every 10 milliseconds actually how confident the model is about the answer is giving to the user. And that kind of features around Diarization helps people to streamline processes and be able to reduce human-in-the-loop interaction after that. So in a sentence, better product in terms of performances and features around that make sense for people to use the commercial data.
So being a user of pyannote, I can give you an example exactly of what the commercial product brings to the table versus the open source one. The fact that you have the confidence is really amazing, because based on the granularity that you have for the timestamp, you know when you have the transcription, you know what is an end of a sentence. So you know how likely you are to change the speaker, but you're not yet at the end of the sentence. And then you see you have a punctuation, and then you know that, yeah, low confidence, word with a punctuation, likely to be a change of speakers. So you are able to do those kind of trade-off and be more precise. So that's the kind of things that brings on the table. The transcriptions are being on the market faster and faster. It used to be like when we started Gladia 2 years ago, it used to take 45 minutes to do 1 hour on GCP, 20 minutes on AWS. Now everyone is around between 10 seconds and 1 minute and a half for 1 hour. So these 50 seconds on the open source might be okay-ish now, but it won't be like in 3 months, 4 months, 6 months from now. And you will need to go down to the 15 seconds. So that's the one thing. Now, talking about Gladia's experience and why we choose to go with pyannote, stability of the infrastructure is a huge point. And as I mentioned, you have some algorithm in the open source that are in the open source version, and Hervé, correct me if I'm wrong, which is the clustering. So I said, like, you have those bags of vectors, those bag of, I would say, points that are representing the voice. This clustering is being done on CPU on the open source version, and maybe correct me if I'm wrong, Hervé, if it has changed. But the problem is gonna happen is when you have transcription, you're gonna do many things on the GPU and super fast. The moment you go to on the GPU, it's getting extremely slow and becomes the bottleneck of your infrastructure. And the problem with that is, like, with scale, you're going to have, on the one hand, a GPU that's going to be extremely expensive. It's going to go extremely fast. And then you're going to have a CPU that's going to be extremely slow and won't make you enough performance to get the best out of the infrastructure and how much money you're paying for. And that's the reason why you have 50 seconds on the one hand and 15 on the other hand. They were able to optimize that. And I can tell you, operating pyannote by yourself can be a real pain for the infrastructure players like us, because you have CPU workloads that are moving around all the time, and it becomes a bottleneck of the infrastructure, and it's extremely painful to handle. So stability at large scale is a huge topic for us, and that's one of the reasons we decided to go with pyannote, partially for our infrastructure. Sorry, Vincent, but I was referring as a customer what pyannote is.
No, 100%. And I can't advise more to go with Gladia, guys. That's the other part of the question. And and super happy to you've been sharing a lot of things about our partnership, and just to share that also. We are really trying to do something around this product and this technology, and we're super happy to be partnered with top-notch guys like you, and being able to crack this problem and have it this very flexible way in terms of approach. So we can't be more happy to be partners.
Thank you so much. And but this webinar is about diarization, so that's why I'm not talking that much about Gladia. Hannah, I think you have a few other questions in the chat that you wanted to highlight.
There was some that I found really interesting related to the different kinds of audio. So, for example, having multilingual audio or having audio in different languages, did you notice that impacts accuracy, and that there are some languages that may be easier to work with? And I guess, how do you handle situations where there are a couple of languages that are being spoken within the same conversation? That's something with Gladia also try to tackle. And I guess the question of also gender, like male versus female, or having kids speak, do any of these factors complicate your task as well?
Okay, so regarding language, so by definition, speaker diarization is language agnostic, because we are not actually outputting words, so but really the speaker identity. But it's true that there are a bunch of voice traits that impact the accuracy of speaker diarization. You mentioned gender. I think there's I'm talking as a researcher here, but it's well known that the speech female voice is much less represented in training datasets. So that has definitely an impact on the precision of any speech processing approach. The less represented in a training dataset, some kind of data, the less good it will perform in the output. So garbage in, garbage out, right? Coming back to the language, I like to give this example that we had this Greek customer coming to us saying, your diarization is perfect, it's amazing. And what's funny is that we have absolutely no Greek as of today in our training dataset. Even though it's not there, we still manage to get very good results. So it's not so much the language that impact the speaker diarization, but really the acoustic condition, as I was saying, the nature of the conversation, whether it's read speech or very spontaneous speech. That's what makes the problem more difficult rather than the language. There was also mention of child speech. I don't have, to be completely transparent, I don't have a lot of results to report on the child speech. For the same reason I mentioned earlier, there are not that many, for legal reason mostly, there are not that many child speech dataset. It totally makes sense. You don't want to have I'm a father of two, I don't want my kids to have their voice recorded in the dataset. Who knows what it could be used for in the future. So I don't really know how good or how bad it behaves on child speech. And there was a last point. Yeah.
Quickly on speech, I can give an idea, and maybe it's hopefully the same. On speech, you have around 20% less accuracy for female than versus male. And that's due to the representation in the data set. We see less female. Just go on YouTube and see the number of people you have. It's mostly male. So you have that. And for the child, I think we are around something around 40% less than male. So usually you have 90% accuracy, you're around 70, 80% for female, and kids, you go down to the 50%. That's just giving a rough numbers in terms of ASR, but probably something similar on your side. Yeah. Just because of data representation. So
yeah. And there was also a point about mixing multiple languages in the same conversation. So I do have some experiment to back this up. We are kind of robust. We are quite robust to this kind of stuff. I participated to a challenge in the academic world called Displace. It was basically a data set that we were asked to process that contains meetings recorded in India with Indian people switching in the course of their conversation from Hindi language to English and back to Hindi. This is what we call code switching in the jargon, and we actually ended up first on this challenge as well. So we are quite robust to having multiple languages, even if it's the same speaker changing languages over the course of a conversation. We are quite robust to this kind of issues.
And I can confirm this is our specialty, the code switching. We were the first one to do that, and I can confirm that pyannote has been a great partner to have with, because we have the same value prop, being multilingual. Anna, do you have another question?
Yeah, there was a question about, I think we didn't mention that yet, but real-time speaker diarization, and what's the progress there, and how does it affect real-time applications such as live captioning or voice assistants that have to, manage in real time?
So yes, we are really deep right now into the streaming speaker diarization capabilities of our product. Something that we didn't mention, but our CTO is actually the creator of the open source toolkit called Diarization. Some of you may know this is an extension of pyannote that is basically doing speaker diarization in streaming. So we are very well equipped in terms of people to address this particular problem. So what I can say is that our current internal product is still a work in progress, but we have a very nice segmentation. I mean, the segmentation part of our streaming speaker diarization is actually on par with the offline one. That is famous for being very good at detecting overlapping speech, detecting very precisely the start time and end time of each speech turn. We still have a bit of work on the clustering part, where to make sure that the speakers are correctly clustered for the course of the potentially very long conversation. I mean, in streaming, you might have use cases where you have a microphone that is always on. Like we have customers, in the wearable area as well, where you have some kind of device that you wear all day long. So the conversation might become very long. So we need to, before shipping something, we really need to make sure that it's at the same level as our very good offline speaker diarization. So not there yet, but we are working on it.
That's one of the most requested features also on our side. So I've been pushing this on the roadmap for quite some time. So good question, and putting more pressure on Vincent and Hervé's shoulders. Do you have?
Yeah, the future is real time. That's what we're hearing.
We deeply like that as well. We are fully aligned with you guys on that one. And Hervé is very cautious, and you're right to be that cautious. And I won't make my salesperson pop up, but please trust me. From experience, the speed of the team to ship a product that makes a lot of value is incredible. So yes, stay tuned. You won't wait long.
Thank you. Great. And then there's an interesting question that I think will enable us to talk a little bit more as well about the future of this technology. So there's a question specifically for Jean-Louis, which is that we have an alpha feature that's called speaker re-identification. Whether you could explain about it, what's our roadmap there, timeline, and is that something we're using pyannote or just trialing on our side? Do you want to take that?
That's a good question. So yes, we've been we have an open source roadmap, which is Note. I can share actually in the chat. So we have this roadmap that is open source, and I will let you share it. And the most requested feature was basically to be able to recognize speaker across transcriptions. So that's not something that we can directly do with pyannote. We don't push the data to pyannote directly. What we do on our side is we compute the transcriptions segments or utterance, if you wish, across multiple transcriptions, and then we calculate the embeddings using some algorithm that are well known. It's called ICAPA TDNN, which is probably what Hervé has behind the scene in pyannote, which is the signature algorithm, the algorithm for signature. It's just that we need to combine both the transcription on the one hand and the diarization on the other hand. That's why we do it on our side. This feature has been the most requested. It's been shipped a few months ago. We are like still iterating with the customers that we have. It's able to register on the fly unseen speakers based on a certain threshold of confidence. Otherwise, going to look into the vector database at high speed and be able to actually find the most relevant speakers and boost some of the speakers if you know that a person XYZ is already in the meeting or already in the conversation. So if you are willing to look at it, please contact us directly. We'll give you the documentation. It's private for now. But happy to have your feedbacks. I know many of you are looking to have this. So we're going to give you, as I said, that speaker 0 is the identifier ABCD. We don't keep names. And you shouldn't, on your side, keep both the signature and the names. You want to keep like both things separated for security and privacy purposes. So that's why we keep pseudonymization, and you should do the same. So it's good that we separate vendors in those cases. I know pyannote has a feature pretty similar to that. You could do that independently with pyannote. Maybe Hervé and Vincent, you can comment on that.
Go ahead.
Okay. we do provide a voice printing speaker identification feature on top of speaker diarization. So basically how it works is you first send us a short excerpt of the voice of the people that you want to later recognize. You get back a voice print. So as Jean-Louis mentioned, you are in charge of storing the voice print. We don't store them for the exact same reason that you mentioned. And then later on, once you have a conversation between a speaker that you want to diarize, you can also pass along the voice prints, and it will automatically tag each speech turn with the right speaker. Instead of having speaker 0, speaker 1, you'll get Jean-Louis, Vincent, and potentially speaker 2 if the third person is not among the voice print that you provided. And so it's readily available either on the API or in our on-premise package as well.
Thank you, everyone. And so I guess from there, since the title of the webinar was about the future of voice intelligence specifically, because we know that speaker insights, they hold a lot of value. And so now that you're working with this technology, how do you see it evolve? I guess from the kind of more pragmatic, realistic scenario, but also what do you think would be like a really exciting evolution of this technology, and what could we possibly learn from transcription as well as diarization about the speakers, and how could businesses leverage that even more and derive even more value from it in the future?
Do you want to take it? Yeah, I think, well, there's a lot of things here to be to that kind of challenge us and see how the ecosystem will go. I think from our perspective, with the speaker focus, we really see that there is much more in voice than words, and there are a lot of things around voice, around what's being said, that makes a lot of sense. We know that we want to go deeper into what a speaker has to offer in terms of content, of things to understand. So prosody is one kind of thing that we are looking at to give more elements to be able to share more context and more things around how things are being said. We really see also us working on what we call the non-speech vocalization. So people coughing, laughing, that hesitation. So giving a lot of things around the diarization around speaker that actually can help people and help businesses and teams to understand what's around the speakers, to be able to to elaborate on that, going to sentiment, to emotion, so to understand context around the speaker. And we really see us as like providers to this individual and small bricks that could be assembled by our partners. I don't know, Jean-Louis, from your perspective, how you do imagine that?
What I see in voice in insights is that I usually say, so I'm a nerd, so maybe people won't get the reference, but Bilbo the Hobbit is one of my favorite books. And it's one of the books of Tolkien. So, and the number of tokens or let's say words you have in Bilbo is the equivalent of 5 hours of speech. So every day you generate a full Tolkien book. And I do believe that you have so much information in the voice, not only the words, as you said, but also the emotions and all the things that goes with it. I'm passionate about voice, so I guess that's something that we have in common, but you have so much more in voice than you have in the written modality and it's unexploited. If you think about the companies, how many books they are throwing out of the window every day. All the elderly people that are in those companies that have a lot of expertise, they didn't write those procedures and all these things in whatever document. And if they were to do it, would they write totally what they have in mind? I'm sure they will say it, but I'm not sure they will write it. And so my point, you have so much emotion, so much things that you are able to emphasize in the voice, etc. That to me, voice is the future, and keyboards were just an intermediate modality for us to communicate. But because speech was not good enough, now that we have speech, we have everything. If you think about voice agents, I'm going to give you an example. Voice agents to me are the same as ads in the future. Company will give you part of the traffic as a voice agent, and they're going to see the conversion of your outbound traffic. You're going to have A/B testing on your outbound campaigns through the phone to change your utility bills, going from one energy provider to another, right? Based on your voice, they're going to detect your gender. They're going to detect your emotion. They're going to detect your age. And potentially, they're going to detect the type of population you're part of, maybe your geographical origins. You will have a difference in conversion just based on the choice of the text to speech you're going to use to reply to this person when they talk over the phone. Just by having those information in the voice, you're going to have a very different conversion. And because they give you part of the traffic to do A/B testing, and then you're going to have the rest of the contract based on your performance in the conversion, those things that you have in voice will have a huge impact. Those information you have in voice are going to have a huge impact in your business. So voice has way more things than just transcription, just diarization. There are many other things that we need to explore in general and globally in this market. So that's just the beginning of the adventure for us that are passionate about voice, but that definitely going to make a huge difference in the coming I would say months or years. And that's my take on it, especially voice agents. Hannah, do you have some other questions?
There's one that came in. I guess it's addressed to pyannote, which is, when can we expect a release of the voice separation model?
It's the $1 million question. Let's stay tuned. That's something that is on the roadmap. We can have a small preview as we like to continue. Let me just share that we are coming from open source, and we are not like forgetting where we come from. So we started this speech separation product like we did before. So we released a first version that is like more an MVP than a real product, but still it's in the way that we are thinking this toolkit. Then you can download on the as part of there is the pyannote on pyannote Git, on the GitHub of pyannote, sorry. And for what's coming, I think let us some time until the summer to have something that makes sense at a large scale.
You said summer. I'm writing it down, right?
And you might be in Australia. Who knows?
Yeah. No, we don't hide. No worries. But still, and you'll be one of the first to obviously to have the product in your hands, and we value the work we do in front of you guys and with the product we are building, but also behind the scene. And you've been an incredible also design partner and people to work with, and we want to continue that. We want to deeply thank you for like not just making that the what's visible, but also on the background, on the behind the scene, working a lot with us. So deeply thank you.
Yeah, thank you so much. Also, it's helping on the product development on our side too. Hannah, do you have more other questions?
Yeah, one last question, I guess, to wrap this up. It's a really cute question, which was about pyannote, the name. Where does it come from? And yeah, what's the story there?
Oh, yeah. So I saw that question in the chat. So indeed, it comes from Python and annotate. So that's why basically when I started my research, I wrote this Python toolkit to automatically label or annotate an audio recording. So that's how I came up with the name. And on top of that, pyannote is not actually pronounced pyannote. You should pronounce pyannote, and that's actually a French word that means to play the piano, and hence the logo of the open source toolkit. So it's pyannote. In Italian, some might say pyannote, and I also got some pyannotate, but no, it's pyannote.
I just got it. Thank you so much. It's been years and I just clicked. Thank you so much, Hervé. I feel stupid now. Anna, do you have good questions coming also in the chat?
No, I think we can wrap up. There were some really quite more technical questions, so I will let our lovely audience members just reach out to pyannote directly and examine the specific use cases and technicalities that requires. But thank you very much, everyone, for attending. It was a pleasure to have you as our speakers. Again, yeah, we love working with you. It's an amazing partnership, amazing technology. Keep pushing the boundaries of innovation. And yes, this recording will be available. So for those of you in the audience, feel free to share it and reach out to the speakers directly if you have any more business or technical questions that I'm sure they'll be happy to explore with you as well.
Well,
thank you so much.
Very much.
It was a great.
Thank you, everyone. Goodbye.
Bye.
Goodbye.